Hello, and welcome back to Summer Work Help for Calculus 1. Question number 14. 14 deals with everyone's favorite thing, the unit circle. So the question says, identify the components of the unit circle without any outside resources, which means from memory. All right. So, this is summer work. This is not a test. So there's really nothing preventing anyone from just like looking up the unit circle and filling it in, right? And like if students do that, like that's better than nothing, because like at least you're getting that kind of that muscle memory. But that's not really what the point of this question is asking you to do. This question is sort of saying, like, can we sort of reason through, if you were given a blank unit circle, can you fill it in from memory, right? Which may or may not be a component of this class, right? That's still kind of an open question as to whether the unit circle will be provided or not. But I think that a number of students kind of struggle with filling it in, but there are patterns here, right? And there's ways to sort of think about it. You're not memorizing like several dozen different things. You're just like kind of memorizing like a handful of things, and then the rest of the unit circle kind of fills itself in almost, okay? So, try to do this like just you and the paper, right? Nothing else, right? And if you struggle with it, feel free to look it up and see, all right, try it again. And then this video will also kind of show you how to reason through the entire unit circle if you have to fill in a blank one, okay? So some hints here. It's kind of like three parts. So the blank that has a degree symbol above it, right? So this guy, right? That's a degree measurement, okay? And on the unit circle, all of the blanks are going to be between 0 and 360, including 0 and 360. All of them are multiples of 15, and then after 0, the first one starts at 30, okay? So they're all multiples of 15, and the first one starts at 30 degrees, after 0 degrees. Then you've also got the same angles, but this time measured in radians, all right? That's between 0 and 2 pi, again, including 0 and 2 pi. All of them are multiples of pi over 12, and the first one after 0 radians is pi over 6. And then the third component of the unit circle is like the actual like information itself, which is on the outside, which is on the unit circle, which is the ordered pair, and all of them are XY coordinates on the unit circle. Now, as a reminder, the unit circle is called the unit circle because the radius is 1, okay? So you're going to want to remember that. The radius of the unit circle equals 1. And all of the values on the unit circle, all of your X and Y values, X is between -1 and 1, including -1 and 1, and Y is also between -1 and 1, inclusive. So it includes -1 and includes 1. All of the values on the unit circle, all of your XY values, you have 9 choices, okay? 0, plus or minus a half, plus or minus root 2 over 2, plus or minus root 3 over 2, and plus or minus 1. So all nine of those are your options for all of your X and Y coordinates, okay? So let's get into it. The first thing we're going to do is we're going to do the degree measurements, all right? So this is the entire blank unit circle, all right? So we're going to start with these guys. Right? So all of those, right, that I just quasi highlighted, right, all the ones with the degree measurements, I'm going to start with those. And I'm going to go in order. Oh, no, I'm not going to go in order. Never mind. I'm going to go in a different order. My bad. So to begin, start where kind of everything starts, which is at the positive x-axis, 0 degrees. All right. So 0 degrees means you don't move anywhere, right? You start on the positive x-axis, and then you don't go anywhere. All right. So that first blank is 0 degrees, and then the way that I fill in the unit circle is I then go over to the left. I go over here. Okay. So I know that half a circle is 180 degrees. Right? So it kind of makes sense that like you go halfway around, right? And now you're halfway around the circle. So when you're halfway around the circle, that's 180 degrees, right? And then if you keep going, well, you've made one full circle, so then this is 360. Notice that 0 degrees and 360 degrees are in the same spot, right? They're called coterminal. So 0 and 360 are the same thing. They're the same angle, okay? So they're coterminal, so they're in the same spot. Then what I do is I fill in going straight up and straight down. So up here at the top, well, that's halfway between 0 and 180, and I go straight up. Well, halfway between 0 and 180 is 90, right? Also, notice that 90 degrees is 90 degrees, right? It forms a right angle, so that kind of makes sense. Also, if I go straight down, well, that's directly between 180 and 360. It's also 180 plus 90, which is 270. Okay. All right. Now what I'm going to do is I'll focus on the first quadrant. And all of my angles, actually in all four quadrants, rather, in all four quadrants, the angle that's in the middle is going to end in a 5. Okay? So I'm talking about this guy, this guy, this guy, and this guy, right? Those are the angles that are in the middle of each quadrant, all right? Quadrant 1, 2, 3, and 4, okay? So the ones that are highlighted all end in a 5, and they're also halfway between sort of the angles that form the axes, right? So here in the first quadrant, I'm between 0 and 90. And the middle angle is directly between 0 and 90, which is 45. So that angle is 45. If I pop over to the second quadrant, the middle angle, it ends in a 5, and it's directly between 90 and 180. Now, if you don't know what that is, you can always just average them. You can do 90 plus 180 and then find what's half of that, but it's going to be 135. Right, that's the angle that's directly between 90 and 180. In quadrant 3, again, the middle angle ends in a 5, and it's directly between 180 and 270. And if you don't know what that is, again, you can add them up and divide by 2, and what you'll get is you'll get 225. And then in quadrant 4, it's the angle that's directly between 270 and 360, or the average of 270 and 360, which is 315. Also, not coincidentally, notice that from 45, if you add 90, you get 135. If you add 90, you get 225, and if you add 90, you get 315. Okay, another way to think about it. All right, I'm going to go back to quadrant 1. So I'm only missing 2 more angles in quadrant 1. I've got the angle that's closer to 0 and the angle that's closer to 90. Well, the hint, remember the hint? The hint said that you start with 30. Okay, so that small angle is 30. And then the other angle, the one that's closer to 90, well, that angle is directly between the 30 and the 90, right? Also, it's 30 more than 30. So 30 plus 30 is 60, and then another 30 gets you to 90, okay? We have now completely filled in the first quadrant. And that's great, okay? Because the first quadrant is by far the most important quadrant. So if you're ever going to focus on something in the unit circle, you want to make sure that the first quadrant is solid, because then the rest of the quadrants follow the same pattern, okay? I can keep going now, because what's going to happen is all of my remaining angles, I'm just going to keep adding 30, okay? So 60 plus 30 gets me 90, which is already on the unit circle. And then when I add 30 to that, I get my next angle, which is 120. If I go 30 more, I pass the 135 and I get 150. Oh, I forgot to mention, notice that the 45 is directly between the 30 and the 60, and now in quadrant 2, notice that the 135 is directly in the middle between 120 and 150. All right. So we're at 150. I add 30, that gets me to 180, which is already on the unit circle. We filled that in. If I add another 30, I get 210. If I add another 30, I pass the 225 and I get 240. If I add another 30, I get the 270 that's already on there. If I add another 30, I get 300. If I add another 30, I pass the 315 and I get 330. Again, notice the 315 is between the 300 and the 330. And then from the 330, if I add 30, I get 360. And I'm back where I started, which is coterminal with 0. At this point, I have now filled in all of my degree angle measurements. Great. Next step, the radian angle measurements. All right. So now I'm going to do basically the same thing, okay? But I'm going to express all of these angles in radians instead of degrees. All right. So this is just another piece of information that's on the unit circle, is that the unit circle references angles in degrees, and it also references the same angles just using a different system of measurement of degrees, but they're the same angle. All right. So let's go ahead and get started with the radians. So the radians are just the blank line without the degree. And again, similar to degrees, start with 0. Right? 0 radians means I don't go anywhere. I just stay in the positive x-axis, which is where angles in standard position start. The one key conversion between degrees and radians that you need to know is that pi radians is equal to 180 degrees. I'm going to put that up here. Okay? You got to know this. 180 degrees is equal to pi radians. That's the one conversion that you really got to know, because all of the other conversions are based off of that. All right. So that's sort of the key connection between degrees and radians, is that 180 degrees is approximately 3.14 radians, but it's exactly pi radians. So I filled that in. Now, 90 degrees, well, 90 is half of 180. So it stands to reason that if I'm going to look at degrees, I'm going to take pi radians, and I want half of that. Well, half of pi is pi over 2, literally, right? So at 90 degrees, it's pi over 2 radians, just like pi radians is 180, pi over 2 radians is half, which is 90 degrees. Right? If I look down at 270, well, notice that 270 is like 3 chunks of 90, right? 90, 90, 90 gets you to 270. So with radians, it's, again, stands to reason that it would be the same pattern. So it's pi over 2 plus pi over 2 plus pi over 2, which is 3 pi over 2. A little sloppy there. Let me rewrite that. 3 pi. Okay. So 270 degrees is 2 pi, or 3 pi over 2 radians. And then I went a little out of order here, because if I go 90 more, right, or from the 180, or sorry, from the pi radians, if I go another pi radians, I'm at 2 pi radians, which is, again, coterminal with 360 degrees. All right, now we've got the rest. Now, all of the remaining radian measurements that are indicated on the unit circle, all of them are fractions, and all of them have a pi in the numerator, okay? So they're all fractions, and they all reference pi in the numerator. We've got to figure out what's what. In the first quadrant, I'm going to start with the angle that's in the middle, which we know to be 45 degrees. Notice that it's in the middle, and it's directly between 0 radians and pi over 2 radians. Okay? It's half of pi over 2. right? Just like 45 is half of 90, in radians, it's half of pi over 2. Well, if you take pi over 2 and divide that by 2, you just essentially you're multiplying the denominator by 2, which means you're at pi over 4, right? 1/4 is half of 1/2, right? So in the first quadrant, your middle angle is pi over 4, because that's half of pi over 2. In the second quadrant, in radians, just like 135 is directly between 90 and 180, the middle angle here is directly between pi over 2 and pi. Well, pi over 2 is half, and pi is like 1 full unit, right? So the number that's directly between 1/2 and 1 is 3/4. Okay? So, and then you just include pi. So this angle is 3 pi over 4. Also, notice that if we start at pi over 4, and then you add another pi over 4, that gets you to pi over 2, because that's 2 pi over 4. And then if you add another pi over, so we're adding pi over 4, right? And again, 2 pi over 4 just simplifies to pi over 2. If you do that again, and you add another pi over 4, well, now you've got 3 pi over 4. All right, and get rid of this, because we certainly don't need more stuff on the unit circle, but just a way to think about it. And then if you add another pi over 4, well, that's 4 pi over 4, which is just pi, right? 4/4 is 1, so that's 1 pi. In the third quadrant, in degrees, the middle angle was 225, because that's directly between 180 and 270. Well, in radians, we're looking for the angle that's directly between pi and 3 pi over 2. Well, this is where the fractions start to get a little complicated. But suffice to say, it's more than pi, right? So the numerator is going to be ignore pi for a second, but the numerator is going to be larger than the denominator because we're more than 1, right? Notice that there's a pattern here so far that the two middle angles, the denominator is 4, right? So it's pi over 4 and 3 pi over 4, and guess what? That's going to continue. Okay, so just like all of your middle angles end in a 5, all of the radian measurements are over 4. And I'm actually going to cheat a little bit. I'm going to go to quadrant 4. I'm going to put that over 4 right now because I know that's there. Okay, so all of your middle angles in radians, the denominator is 4. Now, it was 3 pi over 4. If you add one more and you get 4 pi over 4, well, that's just pi. But then if you add another one, you get 5 pi over 4. And that goes right there. That angle is 5 pi over 4 radians. Now, if you add another one, you get 6 pi over 4, but 6 pi over 4 simplifies to 3 pi over 2. So now you're here, okay? But if I go one more, I'm looking for the angle that's directly between 3 pi over 2 and 2 pi, right? So if you take 5 pi over 4, you add 1, you get 6 pi over 4, and if you add another one, you get 7 pi over 4. And then if you add another pi over 4, you get 8 pi over 4, which is 2 pi. Right? Now we're not going to write 8 pi over 4, but it is the same thing. All right. Now, going back to the first quadrant. Going back to the first quadrant, we're looking for what's the radian measure at 30 degrees? Well, the hint, don't forget, gave you a hint. The hint start after 0 radians. The first one is pi over 6. And unless you want to convert 30 degrees, which you can do, you can convert 30 degrees into radians, or you just kind of like remember that the first one's pi over 6. Now, what's going to happen is there's a couple ways of looking at the remaining angle. First of all, you can convert 60 degrees, okay, or you can sort of, well, notice that 60 is double 30. So if you double pi over 6, you get 2 pi over 6, which simplifies to pi over 3. Okay, so the first quadrant is done. which again, our priority is the first quadrant, okay? But let's go ahead and fill in the other radian measures. Now, for the other radian measures, this is kind of how I think about the rest. When I'm thinking about the angle at 120, I notice that like from this pi over 3, if I add another third, I get 2 pi over 3, and that goes right there, right? Just like from 60 to 120, right? Just like this, sorry, just like this is plus 60. Well, this is plus pi over 3. Okay, so get rid of, again, I don't want extra stuff on the unit circle. We've got enough stuff going on, so I want to make sure we erase all this extra notes that we're doing. All right, but that angle right there is 2 pi over 3. And then I guess, yeah, no, we should probably go in order. Otherwise, we're going to be bouncing around too much. The other angle that's in quadrant 2, if I look at, well, if I look at this angle over here in the first quadrant, pi over 6, notice that if I add another sixth, I get 2 pi over 6, which is here. 3 pi over 6 is here. 4 pi over 6 is here, and then 5 pi over 6 is there. Okay? So that angle's 5 pi over 6. And then 6 pi over 6 is just pi, because your 6's would cancel. Let's keep going. The next one would be 7 pi over 6. All right? And then I guess I'll actually just keep going in order here. So if I add another one, I get 8 pi over 6, but 8 pi over 6 reduces to 4 pi over 3, which notice if I go from here and if I add pi over 3, I get 4 pi over 3. All right, so that was 8 pi over 6. If I add another one, I get 9 pi over 6, which is here. 10 pi over 6 is the same thing as 5 pi over 3. So that was 10 pi over 6. And then another pi over 6 gets me to 11 pi over 6. And we have now filled in all of our radian angle measurements, which together with the degree measurements means we have now labeled all of our angle measurements in degrees and in radians. And just, again, try to notice the patterns that are appearing here, right? So all of these angles here have a 6 in the denominator, right? All of these angles have a 4 in the denominator. All of these angles have a 3 in the denominator, all right? And they're as you go around the unit circle, right, they're increasing, right? So in the first quadrant, there's no coefficient on pi. It's just pi over something. And then it's 2 pi over 3, 3 pi over 4, 5 pi over 6, and then by the time you get to pi, you know, that's 2 pi over 2, 3 pi over 3, 4 pi over 4, 5 pi over 5, 6 pi over 6. They all simplify to pi. And then that pattern continues, 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2, 5 pi over 3, 7 pi over 6, 11 pi over 6, and then ultimately back to 2 pi. So not just a random collection of numbers and symbols, but there's patterns, there's ways to, you know, not necessarily memorize this, but just get a little bit more comfortable with it, all right? Now, the final part. The final part is arguably the most important part, which is filling in the X and Y coordinates. And like I said, you've got 9 choices, okay? So it's like multiple choice, but you've got 9 choices. 0, plus or minus a half, plus or minus root 2 over 2, plus or minus root 3 over 2, and plus or minus 1. Those are the only values that can go into the remaining blanks, okay? So Here is how I would fill in the complete unit circle. I would actually fill in the complete first quadrant first, right? I'm going to do these 5 pairs, right? There's 10 blanks to fill in. So there's 5 angles, there's 5 coordinates. And I mean, 0 and 90 are not in the first quadrant, but they border the first quadrant, so I'm going to loop them in. And I'm also going to do them first. So the first one I'm going to figure out is what happens at 0. So what happens here at this angle, all right? So at this angle, if you think about the choices that we have, well, the unit circle, by definition, has a radius of 1. Which means, and I'll make this kind of a thicker line so it stands out, which means if I start at the center and I go all the way out here and I stop here, by definition, the unit circle has a radius of 1. So that length is 1. This value is my x coordinate. So that has to be 1. Because the radius is 1, and I just went straight to the right. Okay, that's a straight line. That's a horizontal line. So that x coordinate has to be 1. Notice I didn't go up or down at all, right? I'm like still on the x-axis. So this has to be 0. Okay, so at 0, my coordinates are 1, 0. And anyone watching this video, assuming you're like older than 12, like, knows this, right? The unit circle has a radius of 1. Maybe you didn't know that, but now you do. But if you know that the radius is 1, well, if you go to the right and you don't go up or down, that means that x coordinate has to be 1 and the y coordinate has to be 0. Okay. At 90, it's kind of the same idea, because with 90, we go straight up like that. And that's 1. Well, if that's 1, it means that my y-coordinate has to be 1, and I didn't go left or right at all, which means my x-coordinate has to be 0. Notice that 0 and 1 kind of like pair together, right? So one of them's 1, one of them's 0, right? I want to finish out the first quadrant. So we could fill in 180 and 270, but I'm gonna finish out the first quadrant. So of the remaining 6, okay, all of these are either 1/2, root 2 over 2, or root 3 over 2, okay? I'll rewrite them. These are our options for all 6 of these, all right? Now the question becomes, which ones are which? The way that I like to think about it is that the middle angle, right, which is 45 degrees, which is pi over 4 radians, the middle angle is where the root 2 over 2's go. Okay? So you can just put them there, right? So root 2 over 2, comma, root 2 over 2. Easy, I think. Well, maybe easy is not the right word, but straightforward, let's say, right? So it's fairly straightforward if you can remember that the middle angle, that's where your root 2 over 2's go, and nowhere else, okay? So now they're actually gone. They're no longer an option. So now we have 2 options for the remaining 4 blanks, the 1/2 and the root 3 over 2. And this is where I think there's a lot of, I think, an opportunity for a lot of students to sort of like reason through this, okay? First of all, these are paired, right? So if one of them is 1/2, then the other one's going to be root 3 over 2, okay? So they're not going to both be 1/2 or both be root 3 over 2, okay? So they kind of go together with any ordered pair, but obviously they're different, right? So it kind of matters which one's which, okay? Now, hopefully we can see that 1/2 is less than root 3 over 2. Right? 1/2 is exactly 0.5. Root 3 over 2 is about 0.86-ish, right? So 1/2 is the smaller number, okay? If I'm trying to figure out what happens at 30 degrees, right? Which one goes first and which one goes second, which is also pi over 6 radians. Well, notice that what I have here is I have my first one's my x coordinate, my second one's my y coordinate. Well, if you think about like what's happening here, okay, if you think about the triangle that gets formed, the x value is going to be larger than the y value. I mean, just look at it. Look at the triangle, right? It's a short, wide triangle. Or let me change the order. It's a wide, short triangle, okay? It's because it's wide, okay, it means that the x value is the larger value. And the larger value is root 3 over 2. The smaller value, okay, because it's short, is 1/2. That's how you can figure out what goes where, okay? Think about the size of the triangle that gets formed, right? And this one is a wide, short triangle. So the x value is going to be the larger value, and the y value is going to be the smaller value. Guess what's going to happen at 60 degrees, which is pi over 3 radians. You do the same thing. Now you don't actually draw the triangle, just try to like visualize it in your head, okay? And I'm having trouble drawing straight lines on the surface. I'll try to get better at that. But this triangle is a skinny, tall triangle, okay? This is my x value, this is my y value. Clearly the y value is the larger value, okay? So it's skinny. So the x value is the smaller number, and it's tall, so the y value is the larger value. So that's how we know how to fill that in. Okay. We have now completed the first quadrant of the unit circle in its entirety. Right? Yay. So now that we have the first quadrant, the rest of the unit circle is going to be, I don't want to say easy, easier than what we just did, I'll say, okay? Because the rest of the unit circle, you can use the first quadrant to inform what goes where, okay? So, if you look at quadrant 2 is going to be the mirror image of quadrant 1. Okay, so imagine that it's almost like you're folding the unit circle like over the y-axis. Okay, so if you take this, okay, and you just like fold it over onto quadrant 2, okay, imagine folding it over the y-axis. Those numbers are going to appear in the same spot in quadrant 2. So these numbers, the root 2 over 2, well, this is also root 2 over 2. All right. These numbers go here. This is also root 3 over 2 and 1/2. And then likewise, these numbers go here. The only difference is that because we're in quadrant 2, it means we went to the left and then up. In quadrant 1, we went to the right and we went up. But now, because we're going to the left, oh, and also, by the way, 1, 0 is at 180, right? But because from the origin, right, to get to my xy pair, I went to the left and I went up. Because I went to the left, it means that all of my x coordinates are negative. All right. Now, if you want to like put those negatives in first, or if you want to put them in like as soon as you put the numbers in, fine, right? Because you don't want to forget, right? So they're not identical, right? They're the same magnitude as quadrant 1, but all of your x values, because you're in quadrant 2, because you're going to the left, all of them are negative. Okay, and this is a root 3. Okay. Quadrant 2 is now done. Quadrant 3. Quadrant 3 is going to follow the same pattern. All right, so in quadrant 3, the middle numbers, that's where your root 2 over 2's go, is at the middle. It's the angle in degrees, it ends in a 5, and the radians, the denominator's a 4. When you see that, you know that that's where your root 2 over 2 comma root 2 over 2 goes. But now we're in quadrant 3. In quadrant 3, everything is negative. So it's negative root 2 over 2 comma negative root 2 over 2. At 7 pi over 6, it's these numbers, right? Because it's the triangle is a wide, short triangle that gets formed, okay? So because it's both wide and short, it means that the x value is your large number, the y value is the small number, and in quadrant 3, everything is negative. Meanwhile, at 4 pi over 3, it's a skinny, tall triangle. So it's skinny, so the x-coordinate is small. It's tall, so the y-coordinate is big, and everything's negative because you're in the third quadrant. Clearly here, you just went down 1 unit, so it's negative 1 comma 0. In quadrant 4, when you hit 5 pi over 3, that is a skinny, tall triangle, right? You don't travel very far in the x-coordinate, but you do travel a lot in the y-coordinate. That means that your x value is small, your y value is big, and you're going to the right, so your x value is positive, but you're going down, which means your y-coordinate is negative. At the middle, you got your root 2 over 2's and root 2 over 2. And your y-coordinate's negative because you went down. And then at 11 pi over 6, you have a wide, short triangle. So your x-coordinate is large, your y-coordinate is small. Let me redo that. Small. And you went down, so the y-coordinate is negative. And just like that, using only our brain, right? We did not use a textbook. We did not use the internet. We did not even use a calculator, right? We just reasoned through it, okay? And it is possible to fill in the entire unit circle just based on what we know, all right? Now, again, I would encourage you to try to do that from scratch, okay? If you struggle with it, watch the video, right, like you just did. Look it up, right? Look up the complete unit circle. It'll take you 10 seconds to Google that. But then try again, like give yourself a day, give yourself a week, and then try to sit down with a blank unit circle again to see, can you fill it in? And if you have a way of filling this in that's not how I filled in, obviously, if it's the right answer, do whatever you want, right? I just wanted to show you how I think about it, how I fill it in from start to finish. So question 14, that's the complete unit circle.